In this video, we're going to talk about the distinction between the population and sample regression functions in the context of a bivariate regression model, where we just have a single dependent variable and one independent variable that's used to explain the dependent variable. In this model, the dependent variable y is assumed to be a linear function of the independent variable x, where beta 0 is the intercept of the equation, the point where it crosses the vertical axis, and beta 1 is the slope, which tells you the amount by which the dependent variable changes when there's a 1-unit change in the independent variable. Thinking back to our earlier discussion when we were talking about conditional expectations, the regression equation that we're trying to fit to the data is essentially given by the expected value of y given x is assumed to be a linear function of x. So what we're going to be trying to estimate are the unknown parameters beta 0 and beta 1 for this population regression function. This is a relationship that we assume occurs in the population as a whole. We're going to use sample data to try to come up with estimates of the parameters beta 0 and beta 1. While the expected value of y given x is assumed to be equal to beta 0 plus beta 1 xi, the actual observed values of y will not lie exactly on this regression line, and as a result, the observed y will equal that conditional expectation plus the random error term that we observe in the population. So we can write the relationship between the observed y and x in terms of the population regression function as yi is equal to beta 0 plus beta 1 xi plus u sub I. The sample regression function is what we actually estimate from the data that we have in our sample. So it's a relationship that appears to exist between our observed values of the dependent variable and the observed values of the independent variable, because we don't know the true value of these parameters. Instead, we try to infer them from the data that we have. And each time you do this, you'll end up with a different estimate, depending on the nature of the sample. So we have to estimate the intercept and the slope parameters from the sample data. The sample regression function is given by the observed value of y is equal to our estimated value of the intercept plus the estimated value of the slope times x plus our sample error term. Or if we just want to put it in terms of the fitted regression line or the sample regression line, the predicted value of y is given by our estimated equation, which is equal to beta 0 plus beta 1 times x. So in the population, the error terms represent the vertical distance between the actual points that we're trying to capture and the population regression function. In any given sample, though, our estimated intercept and slope parameters won't be exactly equal to the true values of the intercept and slope parameters. So when we estimate an equation, we might either overestimate or underestimate the slope and the intercept. So in this case, what happens is the observed error term, u sub hat, will differ from the error term from the population regression function. So we'll estimate an equation, but the observed error terms are going to be the estimates of the errors that we have in our sample, which are not equal to the values in the population because we don't have the actual population parameters, beta 0 and beta 1. We just have estimates of those. That's why in this example, u hat sub I is different from u sub I at that particular value of x for that observation.